Hey everybody, this is Larry. This is day 14, I believe, of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Join me on Discord. Let me know what you think about this farm, which I don't know why, but I've been doing all these. Maybe I just need to clear my cache or something. I don't know. Seems like that was a year ago or so. But anyway, today's problem is 198, house robber. So you're a professional robber trying to rob house along a street. It'll automatically contact the police if... Okay. So, I mean, and this is not the circular version because I think there's a circular version. I mean, this is very similar to the Fibonacci number that or the steps, if you will, that we did yesterday. The recurrence is about the same. But really, I think it is very easy to over-index on memorization when it comes to these things, and I think that one thing that I always kind of talk about in my Discord is about against just memorizing patterns and stuff like this. Though it is probably a good start if you have nothing to work on, but it is if you are able to spend time on really understanding how to come up with these things, then it'll obviously will be better. And the thing that I always talk about is try to figure out the key part about it is just expressing it in terms of a recursive type of formula or function or something like this, right? And then that will allow you to kind of do other things that you can learn from experience, like doing it bottoms up, etc. Yeah, and in this case, I'm going to try a little bit. I mean, N is only 100, so it's not even a big deal. But I'm going to try a little bit to kind of think about, or like maybe the evolution a little bit of how to kind of get to this problem. I don't know if I've already done it in the past, so maybe it's a little bit duplicate. But yeah. But basically, the idea here is, let's say we have a function that, and we shouldn't really talk about. They could have something that's like less, FBI in my house kind of situation. But anyway, let's just say get max or something like this, and then you have another nums, right? Like this is, and then basically you have you can do two things to it, right? So with length of nums is you go to 0, then you have no more houses, then you have 0, right? You can't get any money if there are no houses. Otherwise, then you have two cases, right? You can either rob this house, right? So okay, maybe I'll write it as rob this, right? And that's just, you go to get max, so the current value, which is the first value, plus get max of nums. Now we want to skip the next one because we cannot do two adjacent houses, so then this is just something like this, right? And then don't rob this would just be get max of num sub, because we're not robbing this house, then we're just going to the next house, right? And then we just return the max of rob this and don't rob this, and then of course we kick it off by just getting max of nums, right? And this should be right, maybe, yeah, right? And of course the problem is that this takes too long, right? If you have a bigger case. So let me construct a bigger case, right? That's probably already big enough. And if you run it, you'll probably get time limit exceeded, right? So I'm really going back to first principles here with respect to all these nums. If you already know what I'm going to do, if you already I'll practice, you'll probably figure out what I'm trying to do here with respect to the teaching. But then the thing is that what we notice is that, well, in this problem, in this recursion, we don't really change nums, right? Meaning that this array never changes, right? It's just about what changes is which index that we're processing and so forth. So we don't need to keep track of the order of, you don't have to pass down all the arrays and create new arrays and something like this, because we just need to the index. So then here, now we can convert this to index, right? Yeah. And then here, what does that mean? Well, now we want, what does this mean, right? That means that if index is equal to n or greater than n, say, right? Because that means this means the same thing as before, meaning that if the nums no longer have any elements, that's what this means, right? You have 0 away, starting from that index. And in this case, well, the first index that you're looking at is going to be index, and here you're going to go to index plus 2 because now you're skipping the next one. And in the same idea, we have this, right? Okay, so this is still going to time out, but at least now this is slightly more efficient with respect to space, right? Oh, whoops. And then we start from 0 because we want to start from the first house. Yeah, so it still looks good, and it's still going to time out. And you may wonder why, right? You do the analysis. And of course, this is very similar to the analysis of the problem that we had yesterday with the Fibonacci numbers. That's just going to time out, right? And with Fibonacci, I mean, and you could do a naive interpretation of, or a naive thing of like, okay, there's 2 branching factor, so that means that for every number is 2 to the n, and obviously 2 to the n for even 40 is going to be too big, or even 30, right? Whatever, right? For some small n, it's going to be too big. And of course, if you really want to be more precise, in case that this comes up, like I said yesterday, it's going to be phi. I would say it's phi or phi. I never know. But anyway, 1.6 to the n roughly, right? The Fibonacci. It just takes as many steps as Fibonacci takes, right? Give or take. So yeah, so then the idea here then with dynamic programming is noticing that, okay, every time I call this function, I always get the same answer if the input is the same, right? Meaning if we put in the index is equal to 5, every time we put in the 5, it's always going to give the same answer. So then this is what memorization comes into play. It's because then now you can say, okay, well, if we're going to do the same thing every time, then let's just store down the results so that we can use it in the future, right? And that's basically how I write these for these videos. Yeah, and then basically if we've already calculated this, then we return what we calculated last time. And yeah, so cache of index is equal to this, has cache of index is equal to true, and then return cache of index. And that's really pretty much it. That's all we needed to do. The only thing that you can say is analysis. 988. So the other thing about analysis is, of course, why is this faster? Well, for every input, because everything we do is cached, this is cached, as O of 1 and O of 1, right? So everything is O of 1. So because we have index, we have O of n possible inputs, and each input is O of 1 time and also space. Then in total, we have O of n time and O of n space as a result. And that's pretty much it. And given that n is only 100, that's going to be good enough. Oh no, well, I mean, n is only 100, that's going to be fast enough. I was thinking for a second why it didn't overflow, but I was just thinking about what the Fibonacci number. And it's just addition anyway, and the max is going to be 400 times 100, or divided by 2, I suppose, because you have to skip. But yeah, yeah. So that was a very, very, very quick overview of what we're trying to do with dynamic programming and memorization. And this is, I think, like I said, I'm not really a fan of these patterns. And when I was doing them, these things don't have names per se, but I guess nowadays I would call them suffix dynamic program, because you only care about a suffix, and that's why I keep track of an index. Another thing to note is that this problem is symmetric, meaning that if you just flip the input away, you'll get the same answer in either case, right? So, and also, so there are some properties that are fun to kind of think about as a result of that, though I'm not going to get into it in this particular video. But yeah, I think that's all I have for today. I'm not doing another video today because I need to go for a walk. I've been sleeping all day. I hurt myself again in my walking in my calves, so I'm trying to keep it a little bit active. But I was sleeping instead to kind of, I don't know, hope it heals up a little bit. Anyway, you don't need the life story, but that's all I have though. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.